what is the best method to analyze sentiment of low resource languages like Nepali? Hello everyone. I am Sabu Lama Tamang from Sikkim Manipal Institute of Technology, a PhD scholar under the guidance of Dr. Archit Yajnik, and I belong from mathematics department. So today I would like to talk about our research article, Chunker-based sentiment analysis for Nepali text. So here I will be talking about uh, the abstract of the paper, and I'll be talking about what is sentiment analysis. I'll be talking about what model which we have used for the word embedding and we'll be mostly talking about the methodology portion, and followed by research and discussions, conclusions, and the contribution or the future work that we are planning to do in our later time. So this article mainly represents sentiment analysis of Nepali sentence using a word embedding technique, skip-gram model, and multi-layer perceptron for the classification. As we know that in sentiment analysis, we usually try to analyze what the sentiment is all about in the text, and how we are numerically expressing it is that we use a classifier to denote it as positive, negative, or neutral sometimes. So in our research, we have just taken only the positive and the negative sentences. So in future, we can extend it to even neutral one also. So for this article, we have just stick with the positive and the negative ones. So in this article, we have done the experiment in 2 phases. So in the first phase, we have got an F1 score of 0.6486 for 0.6486, and in the second experiment, we have got an F1 score of 0.6779. So in the later part of the presentation, I will be explaining how we got this and which section performed well. So sentiment analysis is basically a well-known classification technique in computer science that examines people's ideas and perspectives and categorize them according to their nature into various classifications. The most relatable definition that I found throughout the journey of me throughout the journey when I was exploring this topic, that was the definition given by the recent article, that is, sentiment analysis can be defined as the process of categorizing a sentence or text into classifications that are positive, negative, and neutral, sometimes depending on the polarity of the sentences. So moving forward, what model that we used in order to represent all the text into the vectors. So that we have used is skip-gram model. Next topic is that. So before understanding what the model looks like, there are many other state-of-art techniques that is being used to perform sentiment analysis. So that has been broadly classified as 3 categories. So that is machine learning, lexicon-based approaches, and deep learning methods. So now this skip-gram model is a vector representation method, as I have already mentioned, and this was first mentioned or was introduced by Mikolov et al. very very recently. That is 2013. It was in his paper that he introduced two what to wake vectors. One was a skip-gram model and the other one was CVAR. So what I have used in my paper is the skip-gram model. So what is the main objective of this skip-gram model is to predict the context words given the main words. So this model can be more accurately represented by this figure, as you can see in the projector. WT is the context word, and there, using this encoding technique, we can predict the rest of the context words. That is WT minus 2, WT minus 2, WT minus 1, and the remaining that follows. So moving on to the methodology section. So how we have gathered the data set and how we applied this technique, that I will be discussing here. So for the data set, for the Nepali data set, since Nepali is a very low resource language and there are very less data sets available in the internet itself. So there I found a solution to it by referring to Kaggle, because Kaggle is one of the best site to retrieve all the collected data. That includes movie reviews, Facebook comments, Twitter comments. So from there, I have taken the data, and there I have divided the experiment into two sections. The first section is we have taken the sentences and then use the skip-gram model and then the classifier, MLP classifier, and then we have got the sentence as positive or negative. So that is the part A. And in part B, what we have done is we have used the verb chunks. Now, what is a verb chunk? So verb chunk is nothing but some phrase of verb. Okay, and that can be done using parser, and that I will be explaining in the later slide. For the details, that the MLP classifier consisted of this many neurons. So in part A, I have done the sentiment analysis using only the sentences. So here, while performing the experiment, we came across many errors. And what we have done is we tried to analyze the errors and came in a conclusion, and then categorize all the errors into 4 types. And that type has been mentioned over here. Type 1, that is negative words are not available, but still negative classification has been done. And type 2 is positive words are not available at all, but still the model is showing that it is a positive one. And the third one is negative word is available. At least one negative word is available, but still it is showing a positive sentence. And the fourth one is a little unique one. That is, we have categorized it as interrogative sentences, whose meaning is very challenging for the machine to learn. So it was mostly question type sentences. And in part B, we have used the verb chunk. So as you can see in the flow diagram, we have taken data sets, Nepali data set, and then we have got the verb chunks using parser. And then all the it has been encoded using skipgram and classified by using MLP classifier, and then the positive negative results. So then, how is a chunker? How is a verb chunk processed? So for that, we need to understand parser, and in parser, the first primary step to understand before parser is the POS tagging. So for example, I have taken one sentence, Nepali sentence. I have converted it into this English one. So here you can see that the POS tagging is being displayed, and here, as you can see, the verb has been colored as blue. So similarly, it will be more clear if we understand this. So this sentence which I have used in the experiment, I have taken this one. For example, this one, bhai like khelna lagaiyo. This is a Nepali language, and the English translation is brother is made to play. In out here, the verb chunker is khelna lagaiyo, which is just made to play. So so what I have done is, when we have used only the verb chunks made to play. So in this case, the machine could understand better. So these are the experiment. These are the results for experiment 1, where we have just used the sentences. So as you can see, the loss over epoch graph and the F1 score as 0.6486. Now as we proceed to experiment 2, we'll see a change. We'll see improvement in the graph as well as in the F1 score. So there is a change in the graph and the F1 score.
What was the difference between experiment 2?
Experiment 1 had its input as the sentences, the full sentences. But since the machine could not understand it, and since the F1 score was 0.67, so that's why we moved on to verb chunk, and again the same process will repeat. So there we could get the loss of epoch as this one.
Yeah.
And as you can see in the graph itself, this is the most perfect graph any researcher would like to attain. No, for this, because in this graph is a very special graph in analyzing the accuracy. So going more into details of experiment 1, what we have done was, we had 4 types of errors, and among those 4 errors, we observed that the type 3 error was very much in number. Since we can see that, so since there was lot of errors of type 3 category, we thought of improving it in our experiment 2. So that's why we moved on with this experiment type 3. And in order to make you understand more, I have given example of each type of error. In type 1 error, since the English translation is given here, brother is singing song. So this was being detected as negative sentence. But here the negative words are not available, right? So that's why this was categorized as type 1 error. And in type 2 error, it was detected in type 2 error, the sentence was forlom demon. So this is obviously a negative sentence, but this sentence was detected as a positive one by our model. So in next type, that is type 3, and the English translation is given as Ram did not go to the market. So this was detected as positive sentence, but it was a negative one. So here, since this is all the neutral words also has been taken as negative one in our paper. So that's why it is taken as positive sentence. So in type 3 also, Ram wasn't made to go to the market, was detected earlier as positive sentence, even if negative word lagaina has been was there. So in this type 3 error, Ram wasn't made to go to the market. So this was actually a very neutral sentence. And the last error, that is type 4, which is basically interrogative sentences. So here, this was the most difficult error that was detected, because in this, in order to make the machine understand this type 4 error, we need to make the machine understand the semantic of the whole sentence. So this error we could not improve in our present work. So here, this was the summary of the two experiments. As you can see, the overall accuracy in the first experiment was 68%, whereas in the experiment 2, it was improved to 85%. And the F1 score was 0.6486 in experiment 1, and in experiment 2, it was 0.6779. And here in the whole journey of experiment 1 and 2, the type 3 error, the only error which we could work on was type 3 error, and that we could improve by 90% in the experiment 2. There are a few challenges related to Nepali language, and Nepali is also my mother tongue language. And there are few challenges, like, for example, in English, when we call it brother is playing, or so this is a very positive sentence, no? Brother is playing football, suppose. Brother is playing a football. And the other negative sentence would be brother is angry at her, brother is angry due to some other reason. Brother is angry due to some issue. Okay, so that way we can that way we can easily identify which is a positive and a negative sentence. But in Nepali language, this is a very sensitive language, I suppose, because as you can see in this example, this Nepali phrase is there and English translation is there. I hope you can understand. It is saying that bhai like Hildena. It almost looks similar. This line, the first line, line 1 and line 2 looks almost similar, but at least even if one word has what you call it, one word is being, one letter has, if there is some change in the letter also, the polarity changes. So that way, this is one of the most important or most notable challenges that is in Nepali is with. So that I have found out in during my research journey. And the second one is there is an absence of well annotated corpus, which makes sentiment analysis task in Nepali language a challenging one. So these were the challenges I came across while studying NL, natural language processing in Nepali language. And about our future work, what can we do next? Apart from what we have done in our first article, is that we can extend this same research to tense classification. For example, a Nepali sentence has been given, we can predict whether it is a past tense, present, or future tense. So that way we can extend. And similarly, we can use the same technique for other low resource languages. For example, there are many other native languages in India. In Sikkim itself, there are many other tribal languages like budding tribal languages like Lepcha, and in other northeast regions also there are many other tribal, Maharashtra. So there also we can use the same technique. And apart from this, the same technique can be used even to do sentiment analysis of social media comments, election reviews, movie reviews, and book reviews. So basically, in this whole process, in the whole research article, I would like to conclude that the chunker-based sentiment analysis was proven superior to the sentence-based sentiment analysis. So this is all about the authors, and Dr. Archit Yajnik, he is my supervisor for my research, and I am his PhD scholar, and I am in my first year of my PhD journey. So I would like to thank all the all the committee members of the today's seminar, and all the dignitaries present over there, and all my senior research colleagues. I'm really thankful for given this opportunity to present a paper in such an early stage of my research career. So and special thanks to Sir John Hawkins for coming all the way from Australia and making this event a very exciting one. Thank you, everyone.